Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we have a review of congruent triangles. So firstly, what do I mean when I say that two shapes are congruent? Well, congruent means that the two shapes are the same size and the same shape. So what it means is their equal sides come in pairs, and also the equal angles come in pairs. So I'll show you what that means in just a sec. But we will focus mainly on congruent triangles. So if I draw two shapes like this, I'm going to try and draw two squares that are the same size, okay? So let's say that for this square, each side was, say, 4 centimeters, and the same for this square here, 4 centimeters. So of course, if they are both squares, I know I didn't draw them awesomely well, but if they are both squares, then all angles are right angles. So these two shapes here, they are congruent because the sides come in pairs. The angles come in pairs. So all angles are equal and all sides are equal between these two triangles. Okay, so in other words, each side on the first square has a corresponding side on the second square that is equal. Each angle in the first square has a corresponding angle in the second square that is equal. Okay, so they must have equal angles and equal sides. So for example, I could draw something like this, a parallelogram it's supposed to be, but not a rectangle. So perhaps this side here might be 8 centimeters and going up might be 5 centimeters. I could easily draw a rectangle that has those dimensions. So I'll just draw this rectangle, and let's say this is 8 centimeters and 5 centimeters. Now, because of the properties of rectangles and parallelograms, opposite sides are equal to each other. So each side in the parallelogram has a corresponding side in the rectangle. This side and this side correspond. This side and this side can correspond because they're equal. They're both 5 centimeters. This one and this one correspond. This one and this one, right? So we have pairs of equal sides, but here we don't have pairs of equal angles because in a rectangle, all angles are 90 degrees. But in this parallelogram, the angles are not 90 degrees. So opposite angles are equal, but they don't have to be 90 degrees. So these two shapes, the parallelogram and the rectangle, are non-congruent. They're not congruent because although they're sort of like the same size, they don't have the same shape. One's a rectangle, one's not a rectangle. Even though they have pairs of corresponding equal sides, they don't have pairs of corresponding equal angles. So we're now going to turn our attention to congruent triangles. So of course, if I have two triangles that are congruent, then they must have pairs of equal sides and angles. So like this side corresponds to each other, so let's say if they're equal, they might both be, say, 10 centimeters. Then this side and this side equal, perhaps they're both 12 centimeters, and let's just make the other one 8 centimeters. Okay. So, two triangles will be congruent as the same definition I gave before if all angles and all sides are equal. There are pairs of equal sides and pairs of equal angles. Each side in the first triangle has a corresponding equal side in the second triangle. So these two in blue correspond to each other, and the ones in green correspond to each other. Okay? Now you might be thinking, and I hope you're thinking, but hang on, didn't you say that both angles and sides had to be equal? So these two triangles would be congruent only if there were corresponding angles that were equal, right? Well, I hope you're thinking that because that shows some good thought, but it turns out that when we're looking at triangles, we can get away with proving less. What I mean by that is with two triangles, if all sides are equal, then all angles will be equal. That didn't work for quadrilaterals. I showed you an example where two quadrilaterals, one a parallelogram, one a rectangle, they had all equal sides, but they didn't have all equal angles. But in triangles, that's not the case. If they have all equal sides, then they will also have all equal angles. So when we're thinking about congruent triangles, we use S for side, a pair of equal sides, and A for a pair of equal angles. So if I want to show, or I want to determine whether two triangles are congruent, I don't need to check every pair of sides and every pair of angles. I can follow a test. There are tests that I can use. So the tests for congruence between two triangles, SSS, like the one up there. So if I have two triangles and they have three pairs of equal sides, each S is a pair of equal sides, then they will be congruent. They will also have a pair of equal angles. If I have two triangles and they have two pairs of equal angles and a pair of equal sides, then they will be congruent. I don't need to check the other sides and angles. The next one's a little tricky, SAS. So if I have two pairs of equal sides and a pair of equal angles, the two triangles will be congruent. However, this is tricky because the angle has to be in between. So it must be the angle between the two sides, the pairs of sides that are equal. Okay, now the last one I have is RHS, which hopefully you remember means right hypotenuse side. So if I have two right angled triangles and their hypotenuses are equal and another side of the triangle is equal, then they will also be congruent. So again, I don't have to check every pair of sides and every pair of angles. I just want to use one of these tests to determine whether two triangles are congruent. Now, I just want to make clear that the test AAA will come across later, but that's not a test for congruent. So I know it might mess with your head. If two triangles have three pairs of equal sides, they will definitely have three pairs of equal angles. However, if I know that two triangles have three pairs of equal angles, they may not have three pairs of equal sides. Now, an easy example to draw here is if I draw two equilateral triangles. So these are supposed to be equilateral. So let's say 6, 6, 6 and 3, 3, 3. Okay? Now, with any equilateral triangle, all angles inside are equal. They are all equal to 60 degrees. So these two triangles have three pairs of equal angles, but clearly they don't have any pairs of equal sides. So that's why AAA is not a test for congruence. Okay, let's go ahead and look at some examples. So let's say I have these two triangles here. Are they congruent? Well, again, I don't know anything about the angles, but I don't need to. These two triangles must be congruent because there's 1, 2, 3 pairs of equal sides. So this is how we write it. So this side obviously corresponds to that side because they're the same length. So we can write AB equals DE. Okay? Now we have to, when we're showing that two triangles are congruent, we have to write a reason. So the reason was just given. We were just told that they were equal. AC, which is this line here, is obviously equal to that one here. They are corresponding sides. So right, AC equals DF. Again, that was given. And then again, BC is equal to EF given. So the way we write the statement that they are congruent, we say triangle ABC is congruent to the other triangle. This is what this symbol means. 3 lines, like an equal sign with an extra line, means congruent. Okay? Now, when we're writing the vertices, so D, E, and F are the vertices of the second triangle, we have to make sure they line up. So D, this vertex corresponds to this. So because I wrote A first, I need to write D first. And then you'll see that E actually corresponds to B, so I need to make sure I write E second. And then, of course, F and C correspond, so I write F last. So therefore, ABC is congruent to DEF, and the reason is the SSS test, all right? I'm going to do one more example. Please pause and copy this down if you need. So let's look at the two triangles I have in this diagram here. So obviously ABC is first triangle and CDE is the second triangle. So are these two congruent? We just need to find if they satisfy any of the tests. Now, one of the reasons we did all that work on angles in the previous lesson, they do come up in questions like this. So I need to be looking for equal angles and equal sides. Hopefully you've noticed that all the tests had three things. You need like two angles and a side, or two sides and an angle, or whatever. You need three things, okay? So first up, I know that AC equals CE. And that was just given. The line on each of these, so this line here and this line here, means that those two sides are equal. Now, this angle here and this angle here, I don't need to measure them. I know that they must be equal. And we went through this last lesson. They're actually vertically opposite angles. So, that angle in the middle is ACB. C has to be in the middle because that's where the angle is. And this angle here is D. C has to be in the middle again. And the reason I'll just abbreviate is vertically opposite angles. So we've got two. We need one more pair of equal sides or equal angles. So I have parallel lines. This line up the top and this line here are parallel, so there should be some equal angles as well. So this angle and this angle, they form the Z shape. So they are alternate, and if you have parallel lines, alternate angles are equal. So this angle here is angle ABC. B has to be in the middle because that's where the angle is. So angle ABC equals angle CDE. Even if I don't measure them and don't know the sizes, I know they're equal because they are alternate angles. So what I've now found is, therefore, the first triangle ABC is congruent to the second triangle. Now, I need to get my vertices in order. So what's actually happened, and a way you can think about congruent triangles is I can take the first triangle and sit it perfectly on top of the other triangle. Now, I would actually do that here if I rotated the first triangle so that this angle ended up here. So if I rotate triangle ABC, it will a certain amount, it will fit perfectly on DCE. But I can't call it DCE. I have to make sure the vertices line up. So if I rotated the triangle, A would fall on vertex E. So I have to write E first because it corresponds to A. B corresponds to D, and C corresponds to itself. If I rotated the top triangle so it fit on the bottom triangle, C would be in exactly the same spot. So the reason they are congruent, two angles and a side. So I'm done and I've shown that they're congruent. So if I was told, for example, that this angle here was 35 degrees, that means that that angle there must be 35 degrees. Because now that I've shown they're congruent, all sides and all angles must be equal. If I was told that this side here was 8 centimeters, then this side here must also be 8 centimeters because they're corresponding sides of a congruent triangle. Alright, I apologize for the long video. This has been the luckiest maths teacher in the world. Have a great day.